All right, so when I last asked you guys, you said you knew how to do this, right? What's the square root of 25? 5. Now, how did you know it was 5? Okay, because if we break it down into its prime factorization, we get a pair of 5s. So 5 times 5 will give us 25, meaning the square root is 5. We're going to use this same idea, because I know I had also asked you, what's the square root of 24? And a lot of you said, oh, it's about 4 point something. Okay, well, we don't want the decimal. We're actually going to take it and do our factor tree. So do you guys remember factor trees from, like, okay, 7th, 8th grade? So what are two numbers that multiply to 24? 8 and 3. Okay, what two numbers multiply to 8? 4 and 2. What about, how can we break 4 down? 2 and 2. So what we're going to look for are pairs of numbers, just like we had a pair of 5s. Do we have any pairs in this one?
2.
Okay, we have 2 2s. The 2 and the 3 are not a pair. So how we're going to simplify this, if it was a pair, we bring it outside. So I'll bring it out as a 2, just like we did the 5. If it did not have a pair, so our 2 here that did not pair up, multiply them back together inside the square root. So 2 square root 6, that is your simplified radical. This is how you can do every single one, is find a factor tree, look for pairs. If you can pair it up, it moves to the outside. If you can't, it stays inside. So we're going to do quite a few more just to make sure we have the process. So if at any point you have a question, please raise your hand and ask. We use square roots all year long, so we need to make sure that you guys know them at this point. So our next one we're going to do is the square root of 125. So can anyone think of two numbers that multiply to 125? Chase?
25.
Or 25 and 5? Okay, so 5 is prime. What about 25? How can we break 25 down? 5 and 5. Okay, so what do we have a pair of? Oops. Okay, we have a pair of 5s, and then we have something left over that didn't pair up. So the pair we'll write on the outside as a 5, and then what didn't pair up goes back inside the square root, and you have your answer. So we're going to do the same thing with 512. Can anyone think of maybe a number that goes into 512? Does anyone know their divisibility rules? Yellow poster. This is how we can try to see what numbers might go into it. If it ends in a 0, 2, 4, and 6, we know that we can do 2 times something to get to it. If all of your digits, so 5 plus 1 plus 2, if when we add them together, we can divide that number by 3, we can divide the whole number by 3. So if the last 2 digits are divisible by 4, then the 4 will go into the whole thing. So when I look at this, does 4 go into 12? Yeah. So that means 512 can be divided by 4. So we're going to divide it by 4. If you want, you could also start with 2, because you know 2 goes into it. The bigger the number, though, usually the quicker we can get to the bottom of our tree. So 4, now 512 divided by 4, I'll get 1, 28. And then 4 breaks down to 2 and 2. And now I need two numbers that multiply to 128. Anyone think of a number that goes into 128? 32 and 4. So again, 4, I can break it down into 2 and 2. Now what about 32? 8 and 4. And then 8. We can do 4 and 2. And we're finally done. So we have a lot of 2's here. So let's see how many pairs of 2's we can make. So I see a pair here, a pair here, a pair there, a pair there, and this is my odd one out, the one that did not have a pair. So how many pairs of 2's did we have on this one? 4. So that means I have to put a 2 for each one of those pairs outside, and inside will go the one thing that did not pair off. Last thing we want to do is multiply the 2's on the outside together. So 2 times 2 is 4, times 2 is 8, times 2 is 16. So 16 root 2 would be your final answer. Yes, Rob?
So just like the leftover, the one that doesn't make a pair is going to be the one side.
Yeah, when I first started teaching this a long time ago, a student came up with the analogy. You need a date on a Saturday night to leave the house. So if you have a date or a pair, you can leave, go outside the radical. If you don't, you got to stay home. Use it if you want. There was a little freshman that came up with that, so. Okay, any other questions on any of this? Yeah. Okay, negatives inside the square root, we're going to learn about next semester. For right now, you won't have negatives inside the square root. Because when we get negatives inside the square root, it's a totally different type of number, which we'll learn about next semester. Negatives on the outside of the square root are okay. In fact, I have one we're going to do here in a minute. Any other questions on the process of how to simplify? Okay, so let's have you guys try this one. Square root of 80. So on your paper, try at least doing the factor tree. So can you do the factor tree for this? All right, let's see, Gustavo, what did you get for your factor tree?
I got 8 and 10 on top.
Uh-huh.
I did the 4 and 2 for 8 and then 5 and 5 for 10. And then I got 2 and 2 for 4.
You did 5 and 5 for 10 or 5 and 2?
Oh yeah, 5 and 2 for 10.
Okay, I thought that's what you meant, but I just wanted to make sure. Okay, so from there, what pairs did you see? So let's see, Max, what pairs did you see?
What pairs?
2
and 2.
So we have 2 2's, and then these ones are a little spread out, so 2 and 2. So we'll take 2 2's on the outside, and what didn't pair off? Our lonely 5 did not pair off. So this would be 4 root 5 as its simplified radical. Okay, did anyone get that?
Oh, I can't like be the 4.
Because this 4, we always go with what's at the bottom of our factor tree. So this 4 here is broken down into these two 2's. So when we use these, we're using the 4. So that's why we only look at the bottoms of our tree, not anything above it. Good question, thank you. Okay, square root of 200. What are two numbers that can multiply to 200? Justice, what two numbers did you get to multiply to 200? 20 and 10. Okay, so then 10 we can do 5 and 2. And then for 20, what 2 did you guys use for 20? Yeah.
4 and 5.
4 and 5. And then 4 goes 2 and 2. Now, did anyone start with two different numbers, something other than 20 and 10? What did you start with?
50 and 4.
50 and 4. Did you end up with the same,
Yeah.
with two?
Oh no, I got two 5s.
Well, so did we. See, we have two 5s right here.
It's on, okay.
Mine are just separated. Okay, so no matter how you start these, your end values at the bottom of your tree should always be the same. So don't feel like if Justice started us off with 20 and 10, if you chose 4 and 50 or 2 and 100 or whatever, your end goal or your bottom of the tree will be the same. So we have a pair of 2's. We also have a pair of 5's. And then this is the only number, the 2 at the bottom, that did not have a pair, so it's going to stay inside the square root. So we'll have 10 root 2 as our answer. Okay, how we doing so far? Are we doing okay? Show me thumbs up, down, or just to the side if you're just okay. All right. So let's do, I have at least one more I want to do with you guys just to make sure. And that is square root of 147. So what are two numbers that might go into 147? Anyone think they know a number that divides into it?
21 and 7.
21 and 7. And then two numbers that multiply to 21. 7 and 3. So here we have a pair of 7's. So 7, and then the 3 was left out, so it stays inside. And 7 root 3. Yeah.
Would they still be a pair if you did 21 and 7? If you did 7 and 21, I had 21 and 7.
Yeah, because either way, because when you break down 21, that's where you get the second 7. So when we look at we're only looking again at the bottoms. So whether I put the 21 here and the 7 here, breaking down the 21 would still give us the second 7, so we have a pair, and the 3 would still not have a pair. So it shouldn't matter as what you choose or where you put them, because we're only looking at the bottom row. Sometimes if it's helpful, what you can do is rather than just circling from the bottom, write them all out in a row. So this had a 3 and 2 7s at the bottom. There's your pair. This one had 1, 2, 3, a 5, and then another 2. So you have a 2, and then those 2's there. So if it helps to just rewrite once you get to the bottom in a row, and then look for your pairs, you can do that to make sure you haven't missed one, but also to make sure you're only looking at the bottom row. Okay, so if it helps you to write it out after instead of going off of the bottoms, then feel free to do that. Any other questions at this point that you have, or before we get time to work?